Our learning intention is to understand that graphs should have titles, labelled axes, and be drawn to scale if they are representing numerical data. We want to know what an outlier is and to be able to interpret dot plots and column graphs as well as construct dot plots and column graphs. We will know we are successful when we can interpret dot plots and column graphs as well as construct them. Today we're going to look at representing data in dot plots and column graphs. Okay, let's consider a survey of students who are asked to choose their favorite color from 5 different possibilities. We could represent the results of our survey as a dot plot or a column graph. Any numerical or categorical data can be shown graphically using dot plots, where each value is represented by a filled-in circle. More commonly, data is represented using column graphs, where the height of each column represents a number. Columns can be drawn vertically or horizontally. In a dot plot, each dot represents a datum or a piece of data. A column graph is obviously another way to show this data and is very useful when there are lots of options. A column graph is an alternate way to show the different categories of data and is very useful when more than a few options are available. As we said, column graphs can be vertical or horizontal, and sometimes when it's horizontal, people call them bar graphs. Whenever you create any graph, it needs to have all of the following things. It needs to have a title that tells you what the graph is about. You need to label each of your axes to tell us what they are representing. You always need to make sure that your numerical scales are even, and we'll talk in the future about why that's super important. And if you have any non-numerical data, you need to have your categorical labels so people know what the data is representing. To make sure that you are always presenting your data fairly and you're not skewing the results, you need to make sure all numerical axes are drawn to scale. If you see that one piece of data is noticeably distinct from all the other main cluster of points, this is called an outlier. This is a data point that lies far out from what all the other data is doing and may have come about from a lot of different situations. In the future, you'll learn formulas to figure out if a data point is really an outlier, but for now, if you can see that a point is off by itself, we will call it an outlier. Let's practice interpreting dot plots. The dot plot on the right represents the results of a survey that asked children how many pets they have at home. A. Use the graph to state how many children have 2 pets. So I need to go to this column that is the number 2 and see how many dots there are. 1, 2, 3, 4. That means 4 children have 2 pets. B. How many children participated in the survey? So I'm going to count up all the dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. 22. C. What is the range of values? I know that range is the difference between the highest and the lowest. My highest is 8 and my lowest is 0. So I'm going to go 8 take 0, which is 8. So the range is 8 pets. D. What is the median number? Well, if I was to take all of this data and write it in an ascending order, it would look like this. 0, 0, 0, 0, 0. 1, 1, 1, 1, 1, 1, 1, 1, etc. until I got all the way up to 8. And to find the median, I'd cross the highest and cross the lowest. I can do the same thing on the graph as long as I'm making sure that one's the highest and one's the lowest. So my lowest number is 0, and then my next highest is 8. Then next lowest is 0, and the next highest is 3. And I just could keep doing this until I have only 1 or 2 dots remaining. My 2 dots remaining are both in the 1 column, and the middle of 1 and 1 is 1. So my median value is 1 pet. E. What is the outlier? The number that is lying outside all the rest is 8. So 8 pets is the outlier. And F is what is the mode. Again, if I wrote all these numbers out as numbers instead of dots, the number 1 would be there the most because the 1 is the highest number of dots. So I know the mode is 1 pet. You have a go at interpreting dot plots. Let's quickly check your answers. The dot plot shows the number of visits a sample of pet owners have made to the vet in the past year. How many people were surveyed? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 people were surveyed. B, how many people made more than 3 visits to the vet in the past year? More than 3 does not include 3 because it didn't say including. So I need to look how many dots are in any column higher than 3. So that's 1, 2, 3, 4, 5. 5 people. C, what is the range? Range is the difference between the highest and lowest. My highest is 7 and my lowest is 1. 7 take 1 equals 6. My range is 6 visits. D, what is the median? I'm going to cross off highest and lowest until I have only 2 left, or 1. I have only 1 left and it's in the 2 column, so 2 visits is the median. E, what is the outlier? The number lying outside everyone else is 7 visits. And F, what is the mode? The most common is 1 because 1 has the most number of dots. Now let's practice constructing a column graph. Here it says draw a column graph to represent the following people's heights. Now, can I first of all say that when you are constructing graphs, you need to use a ruler. The first thing we need to do is decide which data is going on the horizontal axis, the X, and which is going on the Y. I will tell you that the data that is independent goes on the X-axis. Independent is the data that doesn't change because of the other data, whereas the dependent data depends on this one. So for instance, in this situation, we have a person's name and their height. Now the person's name doesn't change as their height changes, so that must be the independent data. So if I'm thinking their names are going to go along the bottom because their name doesn't change as their height changes. But the heights do change depending on which person I'm talking about. So independent along the X and dependent up the Y. Okay, I've swapped camera angles so that it's a bit easier for you to see how I'm working. And of course, whenever I draw a graph, I have to use a ruler, which I can't do on my iPad. So this is giving you a view of how I'm going to do it. When you're constructing a graph, you don't have to use graph paper. You can use a plain piece of paper or a lined book. But obviously graph paper really helps because it's got this grid that we can use to do our calculations, and it's already got straight lines, which we can use. So step number 1 is to draw up your 2 axes, and we need to do it with a ruler. We want to go quite to the left and quite to the bottom, but obviously leaving ourselves some room for our numbers and our titles. It is best to first use a pencil to make sure you're not making any mistakes. You can go over your graphs later with pens or colored pencils, etc. But pencil is good to make sure you don't make any mistakes. Next, we need to figure out the scale up our y-axis. To do this, we need to figure out how much space we have and how much data we have to cover. So I'm going to measure up my line, and I have 24 centimeters. My tallest height is 150. Once you know how much space you have and how much data you need to cover, then it's really up to you how you figure it out. But everything needs to be even. For me, I'm thinking that I'm going to do a graph that is 15 centimeters big with 10 centimeters of height equaling 1 centimeter on my graph paper. This will give me a bit of extra room up the top. It's really important when you're doing your y-axis that the highest number is larger than your biggest data set. Once we've figured out our scale, the bottom number here in the corner always has to be 0. We will then go evenly up the y-axis. You don't have to write in every value as long as it's even. So I'm going to do every second. Now, you always have to start at 0 and you always have to do all the numbers. But sometimes you might have data that starts very high up. Let's say it starts in the thousands. You don't then want to have this massive Y scale when all of your data first starts up here. So we can do something special, and I'm going to show you here. Let's say my first data starts at 1,200. I can draw in this little symbol here. We go out, across, back up. This little symbol can be used to show that there is a break in the data between the 0 and our first measurements. Please note that we can never do this halfway up a graph. in between data, because this will make our data spread look inaccurate. Now that I've put my data up my Y scale, I'm now going to label it, which I'm going to call it height. I want to put my units in brackets, which is centimeters. Next, I need to figure out my x-axis. I have 5 people whose heights I need to put on here. I've counted and I have 18 blocks along the bottom, and I have 5 people whose measurements I need to put in. So I'm thinking I'm going to give each person 2 blocks, which is 10 blocks altogether. These 8 extra blocks will be perfect for giving me a gap in between each person. I'm then going to evenly draw them out. I'm leaving a gap and I'm doing 2, and this is my first person, Tim. Leaving 1 block, drawing 2, this is Phil.
Leave a gap, 2, this is Jess. Another gap, and this is Don. 1 more gap, and I have Nairi.
Now what you may not know is when we're doing bar graphs, we have to leave a space in between each of these bars. There are only 2 situations when we are allowed to have our bars touching, and I'm quickly going to sketch out these situations. For example, if I had some dates along the bottom, let's say I had the year 2000, 2010, and 2020, and I wanted to compare how many students preferred maths versus English during those times. For each of the years, I could draw my maths column and my English column next to each other, touching. Then I'd leave a gap and I'd draw my next math column, my next English column, gap, and again, go along. I would then use some sort of colored method and a key to let people know what the 2 different colors mean. But because both of the data are representing the same time period, I put them together and they touch. The other situation is when we have continuous data. For instance, if I was given a table of values that said between 2010 and 2020, 50 cars were made, and between 2020 and 2030, 40 cars were made. Because I don't know specifically which date it is, but it's between them, I can then draw my bars that they are touching. Because these bars are representing the dates between these 2 years. These are the only 2 situations when our bars are allowed to touch. Back to our graph, I now need to label these axes. This one I'm going to call name, or I could call person. Now that I have my graph drawn up and I have all my labels, I can input my data. I'm going to start with the first one, which is Tim. Now note, Tim is 1 square in and he's 150 centimeters tall. So I'm coming up to this line because this is in between 140 and 160, which is 150. And I'm starting 1 square in and I'm going 2 across. And of course, I'm going to be using my ruler. Once I've drawn the top of my graph, I'm then going to connect the line down straight with my ruler. Tim is done. Now I'm doing Phil. Phil is 1 block in from Tim, and that's on 120. Here's 120, Tim 1 block over, and of course I'm using my ruler to go 2 blocks across. Once I've done the top, I'm coming down to Phil. Jess is 140. I need to make sure I'm lining it up to where Jess is, and I'm starting there and I'm going 2 blocks across.
Now that I've done my top, I'm going down to make Jess's bar.
Don is 100, and of course it's going to be 1 block away, 100, 1 block away, 2 across.
And I'm bringing it down, and bringing it down.
And lastly, Nairi. Nairi is 130. I'm going across. Now that seems to be in line. I'm just checking. Yes. And I'm going 2 across.
And then bringing it down.
Now that my graph is done, I'm going to need a title, and my title must be really obvious and really just be telling me exactly what the graph is showing. And since I don't really know how these people are connected, I'm literally just going to call it people's heights. I'm going to quickly check that I have all the features of a graph. I have a main title, I have my axis titles plus units, all of my measurements are evenly spaced, and I have category labels. I'm all done. You can choose to use color, but it is not necessary. Now you try draw a column graph. I hope now you know how to interpret a column and dot plot and you know how to construct a column and dot plot yourself.